Welcome back to the history of our search for life in the universe. Now we skip forward to the late 19th and early 20th century to look at the search for life on other planets in our solar system using instruments and techniques that are much closer to the ones in use today. Optical telescopes good enough to see details on the surface of other planets, and spacecraft that visit other planets and transmit data back to us on Earth. So by the late 19th century, enthusiasm for the idea of extraterrestrial life was high for several reasons. Growing acceptance of Darwinian evolution inclined people to see life as the result of natural processes. Advances in astrophysics confirmed our sun as one of many stars, presumably making its planetary system also one among many, and ever-improving telescopes invited astronomers to search the planets in our solar system for signs of life. The Italian Giovanni Schiaparelli and the wealthy American amateur astronomer Percival Lowell, you see Lowell here on the left, had interpreted the markings on the surface of Mars as channels or canals, and Lowell went on to imagine a planet-wide infrastructure program mounted by a Martian civilization, bringing water from polar ice caps to equatorial cities, sustaining a dying populace on a drying planet. Astronomy flowed into science fiction, including popular stories like Edgar Rice Burroughs' Princess of Mars. As you can see here from the cover picture, it's a steamy story. Lowell's career marked the high point. When he began, Martian canals were widely accepted, and speculation on Martian inhabitants was respectable in scientific circles. But soon a gap opened up between popular and professional ideas. Graduate education became a near universal qualification for research scientists. Professional telescopes grew far beyond what could be afforded even by wealthy amateurs like Lowell. Martian canals proved to be optical illusions that vanished in these better telescopes, and 20th century instrumentation, largely spectroscopic, showed Mars to be frozen and airless. Intelligent aliens, they lived on in science fiction, but by the middle of the 20th century, scientists and engineers focused their attention on alien microbes. The first chance to test the microbes of another planet came in the 1970s, when the Viking landers on Mars looked for biosignatures, chemicals whose release from Martian soil might indicate organic metabolism. Neither Viking nor the many subsequent missions to Mars found life, but they have found a history of radical climate change. Mars is now a dusty, frozen, almost airless world, but the early Mars was warmer, wetter, and more Earth-like. Among the many kinds of evidence are extensive erosion features, like the alluvial fan or river delta that you can see fanning into this picture from the left-hand side. These give us evidence of long, wet eras of running water on Mars's surface in Mars's past. It's hard not to see the early Mars as more hospitable. Current Mars missions, including the extremely successful rover missions we've put on Mars's surface, explore that possibility. Mars is not the only potential abode of life in the solar system. Under the icy surface of Jupiter's moon Europa lie huge unexplored oceans that may be rich in hydrocarbons. Could Europa's oceans harbor any counterpart to the rich ecosystems that exist under the ice in our Earth's polar oceans? Microbial life? Macroscopic life? We won't know until we look. The Europa Clipper mission, with the launch target of October 2024, will be an orbiter aiming to determine the thickness and the geological activity of Europa's icy shell, the chemistry of the ocean beneath, and how material may cycle between ocean and surface. This information is hoped to lay the groundwork for future landing missions and eventually missions to probe through the ice into the ocean below. I have to add that Europa is one of the most exciting I have to add that Europa is one of the solar system possibilities that excites me the most. I mean, I would dearly love in my lifetime to peek in and see if there are European counterparts to algae, to plankton, European counterparts to fish or squid or whales. It may be a long shot, but it would be so exciting. So to summarize what we know and guess and hope of life in our solar system, we've observed the surfaces well enough to know, well enough to be confident that there is no other surface life like us. Big, technological, obvious. The surfaces all look pretty hostile, frozen, broiled, fried, toxic, dry. If terrestrial life is any guide, we do best to search for life that may exist in hospitable niches that might be underground or under ice. Perhaps we'll find evidence of past life in eras of more moderate temperature or different atmospheric chemistry. Extraterrestrial life in our solar system is most likely microbial, but it's still worth holding a long shot hope of macroscopic, larger scale life in select niches. And if we hope to find those aliens of science fiction, those smart people that we want to talk to, it seems we must turn our attention beyond the solar system. And in doing so, we're going to meet one of the fundamental problems of astronomy: enormous distances. And we'll look at those enormous distance scales in our next set of lectures.